Good evening. It's my pleasure to welcome Professor G.D. Yadav. Professor Yadav is the National Science Chair of Government of India and Emeritus Professor of Eminence and former Vice Chancellor of the Institute of Chemical Technology, Mumbai. He serves as the Adjunct Professor at University of Saskatchewan, Canada, University of Newcastle, Australia, Distinguished Adjunct Professor IIT Guwahati and SOA University, Bhubaneswar. His patented work on the net zero goal, green hydrogen production, and carbon dioxide refineries and valorization of waste biomass and waste plastics is internationally acclaimed. He was conferred Padma Shri by the President of India in 2016. He has been the recipient of 2 honorary doctorates. He is elected as the Fellow of all Science and Engineering Academies in India, TWAS, RSC UK, ICAM UK, US National Academy of Engineering and US National Academy of Inventors, among others. He has 500 plus research papers, 120 granted national and PCT patent, 8 new patents. He's still active, makes me worried, and 3 books to his credit. He's on the board of 6 listed companies as an independent director. Currently, he is the president of the Indian Chemical Society and the Maharashtra Academy of Sciences. Professor Yadav, he is a poet. He has written the University Song of ICT. He is fond of Sanskrit, Vedas, philosophy, and etymology. It's my pleasure to welcome him on behalf of the Institute to deliver the talk.
Good evening, Professor Harish, my friend Professor Vinod Singh, Professor Jayan Singh, Professor Santosh Gupta, other distinguished professors, fellow students, ladies and gentlemen. I'm indeed very happy to be here this evening to give this institute lecture, and I will try to entertain you for next few minutes. You can interject me if you do not understand something, but I have purposely made my lecture simpler without any equations so that you are not distracted. Ladies and gentlemen, in today's world, we talk a lot about the so-called net zero. What is that net zero and how are you going to achieve it? And what is the position of India with regard to rest of the world? So you can see that this is a very interesting statistics. You know, before the pandemic, in January 2020, the atmospheric concentration of CO2 was 410 ppm. Then within the year, when practically no economic activity was there, we still added 2 ppm. Remember, that time the capacity of the refineries across the world was almost 97.4 million barrels per day. And when during the COVID, it dropped down to 85 million barrels per day. Still, we added 2 ppm. You see, next year, we added 6 more ppm, and it is now 422 ppm. And we are talking about net zero. That is, the greenhouse gas emissions will be literally zero. You do material and energy balance, right? So we have to see that there is no more additional carbon dioxide going into the atmosphere. And with reference to that, we are always reminded of this Paris Agreement or Paris Accord of 2015, where, 195 nations came together and signed this agreement, except one, the mighty one, that is United States. Well, they were worried for their economy. They said, we don't care for the world. Our economy is very important. So that is what they did. And so, however, during, 2020, Joe Biden, who was contesting the elections for the presidency of the United States, he was talking a lot about this net zero. And he promised to his voters that he will sign that accord and create new types of jobs for green energy. And so this was his very first meeting, the Summit on Climate. Our Prime Minister also participated in that, and they discussed a lot. So, and then in 2021, India committed to the net zero in the Glasgow conference. You can see Boris Johnson there and the Brazilian president, that we will commit to net zero by 2070. So the question to me, a researcher like me, why 2070? Because it is a political decision, because you want some additional 20 hours. So my question is, why not 2050? Can we not achieve it by 2050? I resoundingly say, yes, we can achieve it. That is why we require to develop new types of technologies. And we can do it, believe me. Indian science and technology and the industries are capable of doing it, but they must collaborate. They cannot remain in silos and say that, okay, we will do this, and we have enough of time, 20 years additional time to pollute the world. All right. And in the so-called COP27 in Egypt, India asked for something. India said, okay, can you allow us to use our coal for some more time? Because our power plants are based on coal. What did the Western countries say? They said, no, you cannot. You cannot. However, they forgot they are still using petrol and natural gas, which is carbon, right? So they are using two different yardsticks for themselves. And the best part is this is for the so-called NGOs. Many of our NGOs are foolishly guided by, foreign media, and they have interest somewhere else. They are not nationalistic. So more than 10 years ago, I was in Tamil Nadu. I was giving a lecture in Anna University, and all of a sudden the power went off. So I said, look, and our people were agitating in Kudamkolan to stop that nuclear plant. And they said, and I said, what is this? We don't have power and we want to stop that power, whatever we have. Remember what happened last year? After the invasion of Ukraine by Russia, you may call it, inverted comma, because I can't say whether it is invasion or whatever. See, they are giving the example, our NGOs, that Germany has stopped coal, Germany has stopped nuclear power. Germany is a pillu nation. India is a huge nation. How can you compare yourself with Germany? But our people were comparing. And remember what happened. Last year, this is in New York Times. Both these things are picked up from New York Times. They say, this is the great girl, this is the Greta Thunberg. She's an activist. I will not talk about her, but what she said, closing nuclear industry in Germany while increasing coal is a mistake, she said. So they opened up their coal power plants and they opened up nuclear energy. But the same people, our people were telling us to stop it. So when it is your energy need, which is most important, because every country worries for its own energy need, and India should worry for its own energy need rather than going by some ideological thing, okay, we will remain bhuka, but we will not eat this. Something like that. So that is not correct. And so what is happening historically, you see, since actually the industrial revolution started, 1750 is the base year, billion tons of CO2 emitted, United States stops 397, India 510, India is at number 7. But today, if you look at it, India is number 4. If you take EU, European Union, as one single block, otherwise India is number 3 in CO2 emissions. And we are talking about the so-called net zero. So what is going to happen? Remember, this is a very interesting slide. We are talking about net zero. Listen, if you take it as 100% global aviation, covered only 73%. Countries with no net zero target, 27%, almost one third are not there. Then other countries with similar is 29%, European Union only 7%, US 12%, and China 25%. And we are worried. And this is what the so-called ESG goal of all companies have to state their ESG goal. Because I'm involved with 6 different public limited companies, in every meeting of ours, we discuss this. What is the ESG goal? And something which is the climate change strategies, biodiversity, water efficiency, energy efficiency, carbon intensity, and environmental management system. This is discussed every now and then because we are a partner to a treaty which is international. And remember, in today's context, we talk about electric vehicles and smart mobility. But if the electricity generated by coal, it is not EV, it is coal V. Right? Because the coal is used to generate that electricity. So remember at this. So look at the travel emissions, road, passenger, freight, aviation, and others, and shipping. And remember, in this, 60% are from international flights and 40% for domestic flights in the passenger emissions. Shipping industry produces almost 2.5% of CO2. People may not know that. Shipping industry is also highly polluting. Actually, they blame chemical and allied industry. Chemical and allied industry is nowhere. So if you are chemical engineers, you should defend yourself, okay? So remember this. The smart mobility is a new and revolutionary approach to transportation that transforms it into being green, safe, and efficient, and also sustainable. So how do you do that? So remember this. So look at the energy consumed by various modes of passenger transport, and this is freight transport. Trucks, ship, and freight rail, and here you see two-wheeler, four-wheeler, three-wheeler. This is increasing, right? So this is the freight transport, the trucks. So in other words, our pollution which is coming from trucks is very high. They are oozing out carbon. So can we do something about that? See, that has to be a national strategy. It has to be a policy, and this has to be decided by the government. So remember, so how do we get the India's transport greenhouse gas emissions to zero? Remember, this is coming down. That is alternate fuel. So one of the areas which I am working like others, many of you. So this is one of the things which believes that by 2050, we should go to this. And of course, you improve the efficiency, you don't electrification. So, and interestingly, this statistic, so-called freight service demand will grow 5 times, nearly 2,000 billion ton kilometers. In 2020, it will be 5, so 10,000. And since trucks are the dominant part of this transportation, decarbonization is going to be a huge challenge. In fact, I have recently gone to Ashok Leyland and they are going to work with me. They have a very interesting problem, very scientific problem, and they want me to solve that problem for this particular industry. And see, remember, the same thing by road, similar statistics. So alternate fuels is one interesting aspect in this case. Okay? So remember this, electrification and alternate fuels. And you look at the EVs, significant share in 2 and 3-wheeler segment. And I experienced that while I was coming from the airport to the guest house. Huge traffic. And you know, I'm surprised, Vinodji, there are no signals in your city. Why there are no signals? I have not understood that. They are not followed? I don't know, but at least the road by which I came, there was no signal. So, you know, so that means we don't want to stop. We don't want to have any break. Okay, that is the meaning of that. So what is happening, remember, by 2050 buses, you see, you will have CNG, liquids and electric. So in that liquid, you may have methanol, you may have, you know, things like that. You may have ethanol and electric. This percent is increasing from 2030 to this, okay? And so hydrogen is a very important part of this fuel industry. So I'm going to talk a little bit about that. And remember, the shipping sector I mentioned that 2.5% of the global greenhouse gases. Okay, so once again, the green electricity, hydrogen and ammonia, they are going to be our very big fuel suppliers. Ammonia, because it is denser, you can have it at 10 atmosphere, yeah, as against hydrogen, which requires 300 to 700 atmosphere. So it is a good fuel, ammonia. So look, zero carbon fuels, once again, you see that so-called, the biofuels. We talk a lot about this first generation, second generation, third generation, fourth generation. And this is all important here, that we will have electricity and e-fuels. So based on a little bit of this information, I predict something, okay? I'm not a fortune teller and I don't have a parrot with me, but I can certainly do that, right? So let us look at this. India will be a leading exporter of green energy. India plans to have 900 gigawatt, of green energy to be, this goal will be achieved by 2030. So you can imagine how many jobs are there in this. How many jobs are there? That is one interesting fact. And the green hydrogen will be less than $1 per kg. And green ammonia will be a fuel in many, many applications. And I have been saying this green, hydrogen less than $1 since 2015. I've been writing to the central government, make hydrogen economy. Hydrogen should be a given priority. I've been writing, in fact, I wrote many times to the Prime Minister's office also. And India will be the largest economy, $30 trillion. That was not said not by me, but Piyush Goyal. Today we are only $3.2 trillion. And PPP, it is $11.5 trillion, okay? Because our money can buy a little more, right? But to achieve this $30 trillion in next 30 years, we require all manufacturing and not just apps, right? 24% should be there in the manufacturing sector. And I worry sometimes our graduates don't want to go to manufacturing. They want to sit and have the white collar job. It is not going to happen. India will never achieve that unless we have a lot of manufacturing. And see, my belief is that we will achieve this net zero goal much before 2070. We have capability and we have tenacity, and a lot of our new startup companies are coming, the so-called unicorns, right? And if the net zero is achieved, will the world be peaceful? That is another thing. This is a political question, right? World will never be peaceful. That is for sure. You will fight with your wife because you say it is peaceful. There is no, so this is the problem. And then if that is the case, what happens to these sustainable development goals? So I'm going to discuss a little bit of that. Remember, this is based on one of the papers we wrote, which was, very interesting paper, which talks about policy of the various governments. And this has more than 9,000 downloads. The problem with us is that we have carbon-based economy, and that is the reason for the problem today in the entire world. Carbon is the big culprit. So you have the fossil carbon and you have the so-called biomass or renewable carbon. And if you are a chemical engineer, chemist or whatever, you know that how to convert this carbon into renewable carbon at that, into something else, like we have been always doing this. But there is a difference, I will tell you a little later. So the whole problem is the use of carbon-based fuel is the real culprit for greenhouse gas emissions. So in other words, if you reduce the carbon composition, because it is a mix, fluid is a mix of, it's a composition of various different sources, okay? Carbon is one of the major ones, which is responsible. So we have to go down. So whether it is a renewable or non-renewable carbon, it ends up as a carbon dioxide. In other words, we should worry for carbon dioxide, no matter what we do. So look at this. So some of you may be at least chemical engineers or chemists. So I'm showing this slide just to cheer you up, because Jayan told me that, some of your students, they are not enthusiastic about the course. So I'm telling you this. This is a story. You will like it. You have heard about Ramayana, Mahabharata and everything, and there is always a swayamvar there. The girl chooses the groom. Right? If today there was a swayamvar here, and you stand in queue, if you are a chemist or chemical engineer, the girl will never look at you. The problem because she thinks you are the polluter of the world. She thinks that, I hope some of you will marry some chemical engineer. Okay, so the problem, look at this. So look at this, everything surrounding you, beside, backside, front side, show anything which is not using chemicals. Show any man-made product which does not use chemicals, and if you show it, scratch your head, you will get a prize of 100 million pounds, which is waiting since 2008. Nobody has come forward and said this. So I will tell you a joke on this, because I must entertain you also. That is what I promised you. That in 2001, I was the president of Indian Institute of Chemical Engineers, and we had a conference in Bhubaneswar. It was arranged a local chapter, Kalinga chapter. And the chief secretary of Orissa government, he was the chief guest. I was the president of that function, right? And you know what he said? Bhubaneswar will be Cybereshwar. We are going to close all chemical industry. He made a very bold statement, but he forgot I was the next speaker. So I told him, Mr. Secretary, I'm going to educate you today because you made a very, blatant statement, which I don't like. I don't like any industry which pollutes. I'm aware of the fact that some chemical industries do pollute, but chemical industry saves. And if you think that you can live without chemical industry, you will have to leave everything on your body and go home hiding your modesty with leaves and whatnot. Because everything on your body is a producer of chemicals and chemical products. And what happened? That time, during 2001-2, that was a low period for chemical engineers. Nobody would come to the courses. Many places there were vacancies. And you know what I said? From atom to atmosphere, we work in the, various fields, chemical engineers. God is a chemical engineer. I made this bold statement. It does not mean if you are physicist or somebody else, don't take it literally. But then what happened? What happened, I tell you? Very next day, the New Indian Express in Bhubaneswar printed this thing. A UD professor comes and claims God is a chemical engineer. That became a headline. Now the fallout of that, our student in UD they printed T-shirts, God is a chemical engineer, and they were happily roaming up. Now you'll find a video of mine on YouTube, where you write God is a chemical engineer, and that video will pop up. And you know what happened? I said, oh my God, what did I do? So I did a corollary, because every theorem has some corollary. I said, God is a chemical engineer, but chemical engineers are not gods. Otherwise, there will be a problem at home. The husband will sit in the mandir, okay, and would not do anything. That is what I thought. So, see, only thing is going to change here, because Queen is dead and gone. She will be replaced by Charles. That is the only thing. This prize will remain there forever, so long as the life is there on earth. Another problem which I am going to tell you is the waste generation. Today we produce something like 1.16 kg per capita per day. Just imagine, we are already 8 billion people. What do we do with waste? So waste has to be taken as wealth and create some new materials, energy, whatnot. That is what the philosophy is. Otherwise, we will require three Earths, so-called linear economy and circular economy. So what happens? Can this waste be converted into wealth? This waste is only from residential, commercial, and institutions. The industrial waste is not talked about. In fact, incidentally, I chair the Waste Management Committee of DST, Government of India, so I know what sort of waste is being generated in this country. And so you see the United Nations 17 goals. Remember, these 2 goals are very, very important. No poverty, zero hunger, and industry, innovation, and infrastructure, goal number 9. So if you look at this, so chemical engineering has a lot to do with this. That is the reason I put there. Right? You should remember that, because I want to cheer you up. So this is where the circular economy and recycle engineering comes into picture. And chemical engineering will play a very dominant role. It's not just chemistry, because it has to be scaled up. So what is going to happen in that? Remember, you look at the disposal of waste, 1.6 billion tons of CO2 equivalent greenhouse gas emissions only from solid waste treatment. Solid waste treatment. And in 2050, this will become 2.3 billion tons of CO2. So our problem is CO2, right? Our problem is CO2. So what do we do? So chemical engineering will be henceforth called recycle engineering. Chemical engineering will be, so physical, chemical and biological rate processes. Chemical engineering has a simple definition, right? That is, it is a rate processes. We want to increase the rate, so we devise equipment like that. We want to minimize the volume. We want to minimize the reaction time or treatment time in the case of physical processes. So that is, and ultimately it leads to sustainability. So that is the definition. So there is a tremendous scope for creating zero waste society. And so my challenge to IIT Kanpur authorities, can you make your campus zero waste campus? Devise ideas. Find out every year how much waste you are generating and whether it can go to zero. I am associated with Michigan State University, and I told him, I have given them challenge to the president when I had a dinner with him. I said, make your campus zero waste. Then we can talk a lot about this. If we do not, so this is where green hydrogen and green ammonia play. If we do not do this, recycle engineering, we will require 3 years. So, remember, we are talking a lot about this so-called green energy. Solar energy, wind energy, all sorts of energy. So what happens to the, and this we started in around 2000. Now these panels have maximum life of 25 years. That means there are a lot of these panels are available as waste. What do we do with that waste? So that means use solar panels, wind turbines, plastic, batteries, construction and debris waste. This is a real problem for us. So what do we do? So for example, this wind blade waste, see how many are lying here? Where are you going to keep them? So that means you have to reprocess them. What process is used? Unimportant. Then solar panel recycling. This is how they are dumped. See, when we say solar energy, but we are not thinking about post, what is going to happen? So remember, in this battery recycling, batteries have second life. So it is called repurposing. When the battery life goes to 80%, in the case of these e-waste, they become useless, but they have another use. So they can be used for some storing some energy and all, but people don't talk about that. So that market is a very big market. See, nickel, lead acid and lithium ion, we talk a lot about lithium ion, and since we have found some stock in Kashmir, we are gaga actually. So let us look at this, what is happening. So the battery recycling, this was a market of 8.74 billion 2016. So what is going to happen? The use of recovered metal for recycled battery production can help in reduction of CO2 emissions. And also the energy requirements related to mining, because mining is highly energy intensive. So what we do, you have recycling of battery equipment right from plastic, then car covers, then lead, electrolyte, and you see lead batteries have maximum recycling rate in the United States in comparison with others. So we have to look at this. So this so-called circular energy storage, China is a leader and they will have something like 45 billion market by 2030. And during this period, 12 years period, 1000 gigawatt hour of remanufactured and second life batteries will be there. So if you want to start business, okay, start this business. There's a lot of money in that. 75% of electric vehicle batteries, everything from e-scooter to buses, forklifts, trucks, in 10 years time could be remanufactured into other vehicles. So this is another interesting. So battery recycling for sustainability and climate change mitigation. Remember, this is what is happening. So recycle is going to be a very big business for chemical engineers. And with reference to that, I must tell you something about the renewable energy. In 1995 to 2050, we will have renewables of something like 73%, in which what is this? Solar, wind, hydro, nuclear, gas and coal. Remember, coal will be still used in 2050. You might wish it disappears, it will not disappear. because our population is also increasing. And what we require that time, 49,000 terawatt hours. India maybe, I don't know, 2 billion plus in 2050. If we don't control our population, India will be the most populous country, and we will have many, many problems of supply of materials and energy. So you can see that this is, and in this, hydrogen is going to play a very important role. In that 73%, 24% will be hydrogen, okay? And that hydrogen will be both green hydrogen and blue hydrogen. I'm going to tell you something. But when I'm blaming the carbon economy, let us look at the history, something. This is called, you have heard this word biorefinery, right? Anybody who is doing bio and doing something is bio, okay? Biorefinery. They were called this oilery, the well. The blubber of the well was used to extract oil, and that oil was used for illumination and also making soap. That is our first biorefinery. Eventually what happened, because in the North American region, the population of whales started dwindling and came to literally an extinction. But nature is always kind. So these are the so-called oileries, the whale oileries. You can see that. And they used to produce this, this sort of sample. And this is the time when we have this avalanche of coal and crude oil as providers of energy, chemicals, polymers, and whatnot. And that is how it stopped the extinction of whale. Who was responsible for? That is Colonel Edwin Drake. In 1869, in Titusville, in Pennsylvania, he drilled the first well 69 feet underground, and he found that crude oil. That was the beginning of this carbon energy and the carbon as a source. And you see that. So what they did, because it was viscous, they started heating it. So all major discoveries, invention in science are serendipitous. They are not planned, but Louis Pasteur used to say, it is only the prepared mind to whom that chance happens, not unprepared mind. Okay, nobody in the roadside Mawali cannot do that, right? So 1859, Colonel Edwin Drake, so he started heating it, and then so-called, thermal cracking, and they started collecting something. You will be surprised to know the so-called petrol or gasoline had no use, so they used to dump it in sea, lakes, and rivers, because it had no use. It was of no use. Only the kerosene part was good for it. So you can see this was used. Gasoline was abundant. Then you had to wait until 1907, see, and we have to thank Henry Ford for introduction of the first automobile when they found use for gasoline or petrol. 1907. And the whole history changed. You see that 1859, you go during First World War, a lot of things happened. The business expanded. Even in India, 1895, we had the first well drilled in Assam. Okay, still it is producing. So you can see that. Very interesting. The whole concept of this refinery business, because that is the business which gave life, luxury, comfort to us. So what is happening, you see, then during the Second World War, so accidentally once again, they found this clays as catalyst. Now we use zeolite, ZSM5, ZY, zeolite Y, and all sorts of things. But remember, that gave them better quality aviation fuel. And that aviation fuel was superior, and therefore the Allied forces, including Russia, won the war against Nazi Germany. That is the history of technology. But very interestingly, there was a gentleman in Russia called Vladimir Ipatiev. Vladimir Ipatiev was a military general of Russia. He retired at the age of 60, but he was a great scientist. Believe me, many of the scientific developments in the world are developed by these military guys. Okay, NASA, etc. later, but it is military which did it. So these guys were working on catalysis, and whatever we have today in refinery industries, platforming, hydrocracking, hydrotreating, everything, that can be all attributed to Vladimir Ipatiev. So the Americans always look at talent. So UOP, you have heard the company called UOP. They wanted to recruit Vladimir Ipatiev. So at the end, so when he became 60, so he said, now I have retired. So he told his wife he was going to Germany, to Berlin, he told his wife, look at your country for the last time. We are not going to come back to Russia. He knew only German and Russian, no other language. And the UOP guys were waiting for him in Berlin. He said, okay, we offer you anything you want, but you have to come to USA. You know what he said? Yeah, everything is fine, but I have a girlfriend, you should hire her also. So he was a rangela admi, he was a colorful man. So they said, okay, your girlfriend is also hired, but we want you, because they were interested in science and not in his girlfriend. And they took him there. The best part is, Yadav was nominated for Nobel Prize many, many times, but he was not given it. History was not kind to him. You know why? Because he was a military general. Like Mahatma Gandhi never got it. So sometimes you remember this history because Yadav, he gave, I later on admitted the Hall of Fame, like with Vladimir Hensel and all those guys, but Yadav was denied this honor. And his contribution we are enjoying till today. All the refinery processes are attributed to Vladimir Yadav. So now refinery is a very complex business, right? Most efficient business. So you see that refineries are complex which practice catalysis, waste minimization, atom economy and safe continuous processes on a large scale. Million to 100 million barrels, tons rather, per annum. That is the capacity of refineries. And you hardly find any accidents. They use every single atom, including the tar. So their so-called E factor is less than 0.1. That is, the waste is very limited in comparison with pharmaceutical industry. It could be 100. Waste generated is 100 per kg of useful product. So now supposing we run out of crude oil, because it is estimated by 2054 we will not have any crude oil. And we have so many refineries. What do we do with that? So one of the things is, probably by 2050, our capacity even then, if we do not have any additional resources, will be 150 million barrels per day. And that will lead to many things. Or before 2050, due to cheaper biorefinery with net zero gas emissions, this capacity, the so-called refineries have to be converted into biorefinery. That means we have to do retrofitting. What is the important part here? One of the part is this hydrogen, and hydrogen is going to play a very, very important role even now and then. So I'm going to tell you a little bit of this. So I must, he said I'm a poet and all and a philosopher and read scriptures. According to me, the new trinity will be solar energy, wind energy and hydrogen energy. That is my trinity. Like Brahma, Vishnu, Mahesh. Christians say God, Son and Holy Spirit, right? They have borrowed it from Hinduism. I can prove that also on a different occasion. But the fact of the matter is, it is a trinity. Trinity is very, very important in our life. If you are a philosopher, you will know that. So what is my trinity? In this, I will take hydrogen to the top, because hydrogen can give me materials, chemicals, fuels. The others will only give me energy. So this is what is going to happen. So the case for hydrogen economy and net zero, I will tell you a little bit of story on this, that why hydrogen is so important for us now. And we are talking about it. Government of India is talking about green hydrogen and blue hydrogen and whatnot. So remember, last year during these days, this Ministry of Power notified green hydrogen policy. And what did they say? That 50% of countries' energy requirement will be by using renewable energy sources by 2030. So very big task. But what it means for me, it is water and air as the feedstock. Water and air are going to be, so we have Prithvi, Aap, Tej, Vayu, Prakash. You must have heard about the Panch Mahabhut, right? Water. So hydrogen, source, hydrogen and oxygen come from water. So hydrogen, so this green hydrogen and green ammonia, for that we require water and air. We don't require anything else. That means catalytic technologies, separation and all those things. Chemical engineering guys, you should remember this, okay? So don't worry. So what happens? Why ammonia? Remember, this is what you do for green ammonia. You take any renewable source, solar, wind, hydro, and you take water, you split it, either electrolysis. This is what everybody is talking about. And I'm talking about it thermochemical, where I have several patents. And you can produce green hydrogen. Or you take air pressure swing adsorption, you take nitrogen, and you produce green ammonia and green fertilizer industry. This green ammonia, this industry is well developed, ammonia transport. And so ammonia cracking, you get hydrogen. So whatever you do with hydrogen, you will have that. However, ammonia on its own can be used for turbines, boilers, fuel cells, and engine. IC engines can be run with ammonia. However, it is highly corrosive. That is the only problem, because we used to use ammonia for refrigeration, if you remember chemical engineering. Right, so what is going to happen? So by 2050, only two types of hydrogen will be there, blue hydrogen and green hydrogen, and I'm going to tell you something about that. And it will, overwhelm all sectors, power, transport, building, and industry. So what is going to happen? This I prepared from information from European Union, International Hydrogen Council, and Bloomberg New Energy Fund. This business will grow to CAGR of 8% and $150 billion investment by 2030. Believe me, this number will go wrong. I know all statistics go wrong because we are finding every day something new. So this statistic just, guideline. So what is going to happen in 2020, when we have a lot of time to work on some research papers. So you can see that CO2 emission that time was 35 gigatons, billion tons, okay, CO2 gigatons. And we are talking about 1.5 degrees C. If we want to have 1.5 degree temperature rise, in fact, yesterday's paper said that in next 20 years, we are going to get it. So we should be really worried now, not 50 years later. See, it has to be brought down to less than 10 gigatons. That means, see, even if it at 35, 25 gigatons carbon dioxide has to be taken. That means anything related with carbon as a fuel should not be used. That is the main point. So for achieving the net zero, this should be brought to less than 10 gigatons per year. Even otherwise, so this is where hydrogen is going to play a very, very important role. So I'm not going to sing the ballads about hydrogen. You know what it is, the cleanest and safer fluid. Remember this word safer fluid. People think that hydrogen is like a hydrogen bomb. It is not deuterium. It is hydrogen is safer than even this petrol and diesel. So this so-called green, blue, and gray hydrogen, electrolysis of water, which is talked a lot all these days. And so there you have clean electricity from wind, solar, hydro, nuclear, or you can have thermochemical. So we worked a lot on this thermochemical cycle. So I'm going to talk a little bit about that. And the gold standard is zero gas emissions. But really it is zero because you have some other places there, right, where you use carbon. But so we did some LCA also of this. Then, blue. Blue is steam reforming of biomass, bio-oil, and, natural gas, where the carbon comes as CO2. Okay, steam reforming, more hydrogen comes from water there than the carbon which you use. This is where you capture 90% of carbon, then it becomes blue hydrogen. And if that is not the case, then it is gray hydrogen, which is the case right now. All refineries are using gray hydrogen. And 1 ton of hydrogen produces 11 tons of carbon dioxide. And that is the problem with CO2, what we are getting. So yes, another is so-called turquoise hydrogen. Like you do methane pyrolysis and produce solid carbon. So many people have done a lot of work on this, single carbon, wall carbon tubes, multiple wall. But yes, and it is supposed to be a very good technology, but not much practice. But that is a fact, turquoise. So what happens? No matter how you do it, fossil-based energy, natural gas, oil or coal, or the renewable, you have to have hydrogen. It has to be stored. A lot of people are doing work on hydrogen storage. Okay, so this is one area. Many people have written papers. And then your pipeline, you have natural gas, hydrogen, whatever, compressed, liquefied hydrogen, you do to ship, and the end use remains the same. Hydrogen station, fuel cell, and this is the part which is to be developed. 100 years ago, we had the same problem with, this petrol and diesel. Now it is with, but only another part is. So hydrogen production, storage, and transfer. So in the hydrogen economy, if you want to have net zero economy, green hydrogen will play the dominant role, but the technology must be, very cheap and easily adaptable. These are high capital industry. So if you look at this hydrogen specific energy, it has the highest per kg, okay? In comparison with the wood, ethanol, coal, propane, methane, hydrogen, and it can be used for green power generation, transportation, 2, 3, 4-wheelers, fuel cells, IC engines, synthetic fuels, upgrading of bio-oil, and hydrogenation of biomass, green ammonia, fertilizers, green metal, because metal industry, steel industry produces a lot of carbon dioxide, chemical and allied industry is a small component of this, waste plastic chemical recycling, and I'm going to talk about that. So carbon-based fuels and hydrogen, so wherever you have carbon, whether it is biomass or something else, when it is coming out as a carbon dioxide, I can use some catalytic process and convert into something else. So let us look at this. Biomass valorization. So water splitting, importance for hydrogenation and oxidation reaction, these will be very, very important major reactions. So like this is the one place you see that farmers are burning this, the agri waste. All farmers are doing that. They are killing their wealth, So this is, and you go to Delhi, you have this kind of weather. The air quality control, AQI index is very high there. So, and they don't know that all these agricultural waste can be converted into syngas, which will be going into fuels, or bio-oil, liquefaction. And bio-oil has to be hydrogenated, otherwise it cannot be, it has to be polished. Or you this liquid phase reforming, xylose, glucose, lignin, which can go to aromatic in C, furfural, furfuryl alcohol, linoleic acid, hydroxymethyl furfural. These are all platform chemicals. We had benzene, toluene, xylene, butane for refineries. For biorefinery, these are going to be our platform chemicals. So, see, look at that kind of, so I won't go into the chemistry of this. Many of these molecules we have worked in our laboratory. Let there be any source of biomass. You think of any source, where there is a carbon, including municipal solid waste, okay? 50% of MSW is food, so it contains carbon. 11 to 12% is plastic. So a lot of source of carbon in that. So this is what it is. The farmers can benefit by hydrogenation of biomass waste. So no burning and no pollution. Going to Delhi by air will be pleasant actually. Because the particulate matter and the fog, the planes cannot land. So in December, January, you know that those who are going to Delhi. So what it means ultimately, whether you have oil refinery or biorefinery, carbon dioxide is the major culprit. So can we use carbon dioxide as a new oil? Can it be called as a new oil? So let us think on this. So look at this carbon dioxide, and these are all catalytic processes. Urea, methanol, dimethyl ether, formic acid, organic acid, polypropylene carbonate, propylpropylene, ethanol, salicylic acid, very small percentage, cyclic carbonates, carbamates, inorganic carbamates, alcohols, aldehydes. So carbon dioxide becomes a very, very important source of chemicals and fuels. So I'm going to discuss a little bit about that also. So remember how many chemicals and fine chemicals can be made by using carbon dioxide, but it requires technology. Sometimes you can do things in the laboratory, but you cannot convert that because ultimately the money matters. So I always say jokingly as a consultant, the Shethji is not interested in green chemistry or engineering. He is interested in green currency, dollar. If you can give him more dollars, he is happy in your technology. Otherwise he says, okay, wait doctor, whatever you do, am I making money? That is what he asks. So yes, so you see even methanol we can make from carbon dioxide. We have done this. We have got patents also on this. We are selling this technology now. So the so-called methanol economy or Niti Aayog is talking about, because it is a very versatile feedstock. And remember, all these race cars use methanol as a fuel. The flame is not seen. Okay, methanol is used. So methanol can be blended in place of ethanol in petrol and diesel. Okay, it can be done. Yes, and similarly, dimethyl ether can be used. And dimethyl ether is a very good substitute for LPG and diesel. And the same infrastructure can be used. So now I am asking a basic question for the energy expert and government planners. Should biomass be wasted on making low value, high volume biofuels like bioethanol? We talk a lot about bioethanol, right? According to me, it should not be done. Now I am against the current, okay? And I will tell you why I am saying that. There is a reason for that, okay? So let us look at this. I mentioned about hydrogen usage in oil refineries. Remember, this is our current refinery. How they make hydrogen, prepare hydrogen? Steam reforming of natural gas or any hydrocarbon, hydrogen and carbon. And this hydrogen is used in 8 different processes. Right now, hydrogen is used maximum in refineries, which many of you may not know. Refineries use this. And similarly, in the so-called biomass also, hydrogen is required. So either way, you have to promote this. So what happens if we compare the petroleum refinery, biorefinery? If you have studied chemical technology or industry, you know this left-hand side. Right-hand side, from biomass, you see how many different things we are getting, which is not the case with the refinery, right? Refinery is different. So what is the issue? This is functionalization. We functionalize from the petroleum feedstock, which is very easy. Most of these things are catalytic. But in the case of biorefinery, we have to defunctionalize it. And it requires a lot of energy. So the crux of the technology development is, can you defunctionalize it using minimum energy? What sort of byproducts, co-products you can produce? That is the real question. So we did some calculations and published this. For example, we said the path forward is conversion to chemicals and fuels and not refining to fuels. Okay? So for example, based on 1 kg of crude oil, you get 32 megajoule of fuel plus 0.2 kg of chemicals. That is the trend of the refinery today. However, if you take 1 kg of biomass, this gives me only 6 megajoule of fuel, or it can give me 0.8 kg of chemicals. Okay, I can add molecular weight because I can do hydrogenation or oxidation. So based on that time, 97.4 million barrels per day, this comes to something like 215 barrels per second of fuel. And if you convert 100% biomass, it gives me only 10 barrels per second. But if I convert that into chemicals, it gives me 320 barrels per second. And it is very high value. So it is always better to convert biomass into chemicals and fuels rather than convert it into, some ethanol or butanol or all. It is good for net zero, but actually we want negative. Net zero is not going to solve our problem. It is negative which is going to solve our. For example, suppose I take bioethanol, I can make ethylene and see how many chemicals I can make. So dehydration of ethanol, again catalytic, and see how many different types of chemicals I can make. Ethylene dichloride, styrene, ethylene glycol, ethylene oxide. This is in great demand. Propylene oxide is again in great demand. So we can make those chemicals rather than burning it because we know carbon is going to give us positive. Although we are talking of negative, rather neutral, carbon neutral, we should not be using that. So although bioethanol and other biomass derived chemicals can be used to make blue hydrogen, it should not be burnt as a fuel if we want to achieve the net zero goal before 2050. That is a policy matter. And carbon should be used as a source of chemicals. Like bioethanol is more valuable as a feedstock per biorefinery than fuel as our analysis. So we showed it in our paper. And so you use renewable energy, non-carbon based energies, including solar, wind, geothermal, nuclear, hydro and hydrogen. That is what you should be doing. So look at the interesting part. When I do hydrogenation, see cellulose, hemicellulose and lignin, all of these can be converted into a variety of things, and these are all catalytic processes. If you develop a better catalyst, make it continuous, you have achieved. You can develop technology like that. So for example, C5C sugar, in cellulose. So I used to say jokingly to some of the farmers, I don't have to grow sugarcane. I can take lignin and make all these things. I can take any biomass, take C5C6 sugars. I can make anything. There are 6 different types of sugars I can make. Xylose, arabinose, glucose, mannose, galactose, and all those things I can make. So look at lignin. Lignin can be used to make so many compounds, including these hydrocarbons, benzene, toluene, xylene, cyclohexanes, styrenes, biphenyls, or the phenolics, or oxidized products which are very expensive, vanillin, vanillic acid, and things like that. So lignin is a very important source of chemicals. Once again, hydrogen plays a very important role. This is what we have shown here. C5C6 sugars. Remember, oxidation, hydrogenation, hydrogenolysis, condensation, and here, oxidation, lignin, hydrogenolysis, and all those things. In other words, I can produce a gamut of chemicals from biomass by using hydrogen and oxygen. So in other words, water is my feedstock, which I split and get hydrogen and oxygen. That's what I will do. So there are many interesting stories about this green hydrogen, water splitting. There are 216 cycles of this. SI cycle, CECl, FECl, VECl, and CuCl. We worked on both these cycles. And I was supported by ONGC, so I must acknowledge them in the very beginning. So this is why we started continuing with this copper chlorine cycle. So this, we have patented it. We have got several patents. So it is called ICT OEC, ONGC Energy Center Hydrogen Production Technology. We gave an advertisement for expression of interest 3 weeks ago. I've got 24 industries willing to partner with us to take this technology and use it. That includes, transport sector, it includes, all these steel sector, fertilizer sector, and whatnot. So what is the advantage? This is a copper chlorine cycle. Remember, we use copper and chlorine, but it is a closed loop. So only water goes in, hydrogen comes out, oxygen comes out. 1 kg of hydrogen gives me 8 kg of oxygen. So you see, we have a technology level, readiness level more than 8. And we have now a Canadian company which wants to set up this plant there, and they are ready to invest $100 million in that. And even in USA, they are talking about it. What is their motto? This is called 111. Those who are cricket lovers, 111 is called Nelson's Eye. Am I right? Yeah. So here it 111 means 1 kg hydrogen in $1 in 1 decade. That is a technological challenge given by Department of Energy, United States. I'm saying this in 2015, I can produce, hydrogen in less than $1, but nobody listened to me. They say, hey, professor is talking like this. But I showed many calculations, developed some plans. So I tell you something very interestingly. So this is what we did. So we have solar power because we require energy, and we have molten salts. We developed this molten salt. We have got patents on this. And this is our copper chlorine cycle. We just introduce water, we get hydrogen and oxygen, and all these things. Hydrogen, carbon dioxide into methane and higher hydrocarbons. So we have technology for that. So we have hydrocarbons, methanol, dimethyl ether, formic acid, formate, syngas, alcohol, green ammonia fuels. So we can use it, and this is what I've been saying, that we can have hydrogen in less than $1. Okay, so that is the catch point. So everybody is interested in this because the so-called water electrolysis right now is not affordable. It is more than $5–6 per kg. And so they say you have to wait for another 10 years. So since I'm doing it, the ministry also wants me to do it at a faster rate, and I'm given 3 years time too. So we are developing this. We have done this pilot plant in ICD, but ICD is only 16 acres land. I don't have land here. So I'm going to Goa, a bigger place, where I'm setting up a big pilot plant with the help of ONGC once again. So ladies and gentlemen, so look at the electrolyzer cost, 1100 in 2020 per kilowatt. This has to be brought to less than 220 by 2040. Then only that electrolysis technology becomes, viable. You might do a lot of work on electrolysis. You might publish the best of the journals. But technology is something else. Technology requires a different ball game. So what they say, the cost of carbon capture and storage increases in steam reforming of natural gas from $990 per kilowatt hour to $1850. And the target they had predicted is $1.3 to 2.9. Even if you have hydrogen coming at less than $3, they said it is viable. And everybody across the world working in this area. Everybody, believe me, there is not a single institute in India which does not talk about hydrogen. Okay? So you see, if the install cost of PV power can be reduced from about $5 per watt to something like 1, that will be, if solar electricity will be about 0.1 per unit. Now in India, they say solar energy can be purchased in, 2.3 rupees or 2 rupees. But actually it is again a misnomer, remember. Actual, including the taxes, it is not less than 5 rupees. I don't know how much you pay, 8, 9 rupees per unit in your homes. So although we say that it is green energy, government is not giving any tax breaks. Huh? That is another fallacy in the policy. So yes, so what I did, I compared my hydrogen production technology with others. So there is a so-called brown, gray, turquoise, blue, green and green. This is ICT OEC. See, coal steam reforming gives 19 tons of carbon dioxide per ton of hydrogen, coal. If you have gray natural gas, it is 11 tons. The cost is given here. Pyrolysis, the turquoise, it is about $1. Natural gas steam reforming with blue, it is 0.2 tons per ton of hydrogen. This is 1.5 to 2.9, depending. Remember, this is capacity driven. And green hydrogen, renewable electricity, anywhere between 3 and 7.5. And most of the people admit that they cannot produce less than $5, $6, $7. And that is the real problem. And what I'm saying 0.95 cents. Now, so people were asking me probing question. So I said, if I make 100 tons per day, I can produce 95. If my capacity goes down, say maybe 10, my cost will also be $2.5. What I did, I said, supposing there are some hidden costs. Because many times, we are doing heat pinching, we are doing all sorts of funny things. When you develop pilot plant, real chemical engineering is doing scale up. What we find that there are many hidden things. One of the things which you realize, the cost material of construction, MOC. So we have to work on material also. Develop material which is, not corrosive and all. And we found something. So this is a side product. And here what we did, oxygen, I said I will not give any credit to oxygen. Although oxygen, international market is 13 cents per kg on a bigger scale. So you can see almost equal amount of credit I can get from oxygen. So no matter what I do, I can produce hydrogen in less than $1. This is the calculation which we did with different combination, permutation. So that is why we are now putting up a big plant, and we hope that we'll be able to solve this problem. Very interesting, and that is going to give me greatest satisfaction of plant life. So what are the success stories? We converted CO2 into methane and higher hydrocarbons. We have patents, and we can use any CO2 source, which I mentioned to you before. Any CO2 can be used and can be commercialized. So I've got some now interest by commercial, industries. They want to use this technology. So we are going to transfer this technology. Then dimethyl ether, very interesting. This work was done by my postdoctoral fellow under DC Kotari scheme of UGC. Okay, and now this is taken up by Godavari Biorefinery. They are partnering with us for scale up, and we will sell this technology together. Why dimethyl ether? Because it is a good substitute for LPG and diesel. And same infrastructure can be used. Dimethyl ether incidentally is a gas, and dimethyl ether also become a source of chemicals and material. So yes, we develop that also. Then we develop CO2 into methanol. And many people are interested because methanol is a very good fuel. So you see international patents. So this is again, we can make green methanol, green urea, green fertilizer industry. So remember this happened. And biomass platform molecules, we have done many of these things, HMF, furfural, dimethylfuran, valinic acid, libellinic acid, glycerol, and name it. Biodiesel becomes useful only when you valorize the glycerol part of it, because almost 10% by weight is glycerol for biodiesel. So biodiesel, when it was introduced 15 years ago, everybody captured that idea because they got free land. Not really the biodiesel. That was a real case in India. Okay. So you can see that. So now the next interesting part is plastic, right? Government wants to ban plastic, SUP, single-use plastic. My personal belief is should not be done. And I'll tell you why. I will prove by, my ideas. I will tell you why it should not be done. See, there are 7 different types of plastics. I don't have to read them, but what is happening? And this is what they normally say, that how long it takes to decompose. 500 years, never, never, never. What is the meaning of that? Have you ever thought when they present something like this? They say it is not biodegradable. What is your immediate reaction? Oh God, we are polluting earth. And there are so many NGOs who will come with a banner. Who is responsible for? You are responsible for. Who allowed you to throw it in the garbage? Right? You threw it in the garbage because it is free. It is free. If it was not free, you would not have done. So I will tell you solution. So look at single-use plastic. Should it be banned? Look at in USA. I took USA as an example because there are many different states have following different policies. Complete ban, no more, recycle, plastic bag taxes. And India in 2021, we also ban. So even a straw, you cannot use it. You have to carry your straw in your pocket. Right? That is what actually it means that. So how do we do that? And European Union have very funny ideas. So my solution is SUP ban means society is not held responsible and government wants nature to do the degradation. When we say biodegrade, what does it mean? We want nature to degrade it. We are not responsible. We don't want to develop technology. We throw it somewhere, garbage man collects it, and nature takes care of it. And there are 4 ways by which it can degrade. Hydrolysis, photolysis, oxidation, right, or biological degradation. Remember, any biological species, microbe, inserts oxygen from the water into that molecule and creates an epoxide, and that leads to breakage. So, so-called biopolymers are all oxygen-containing compounds, right? So, you know that. So, what is happening here? So, ban is not the solution. So, I am telling you, SUP can be recycled using chemical processes. So, I am going to tell you. So, society's plastic ban means what? Society is irresponsible. We want nature to biodegrade the plastic materials. And is it correct? It is correct. We should ask this question. We don't ask the question. We say government has decided. So, what happens? 3 weeks ago, somebody in Mumbai collected 10 kg of plastic bag from some street vendor and fined him heavily. What that poor fellow can do, right? He has the housewife goes, "Arey bhaiya ji de do mere ko." So he will give you that plastic bag, right? They say you carry your, cotton bag. So use of million tons of waste plastic. How do we solve the previously generated and future? So how do we solve this problem? So remember this newspaper boy coming to your home every day. I hope in Kanpur also newspaper boy comes or somebody vehicle comes. Okay. So this boy comes, the housewife never throws that paper anywhere. Right? In fact, I jokingly say the supplement which they give is worth more in the raddi than reading it. There is nothing there in that. It is all garbage. So it literally goes to garbage. The housewife collects it and sells it, right? And then we reuse it. So similarly, can we not do for plastic? So if we have a mechanism by which we collect it, so my solution is very simple. SCP pollution is due to the free and cheap availability of plastic articles. Encourage recycle at source by deposit policy and digital technology. So this is. So you should have a refundable deposit for every article, like PET bottle or the straw or whatever. Okay? Suppose you say irrespective of the size 1 rupee. You go somewhere in the canteen, you give 1 rupee extra, and when you return it, you get your 1 rupee back. That is recycle, correct? Supposing you are lazy, another boy comes like the newspaper boy, comes to your home, "Madam ji, give me your plastic." It is sorted at source. And municipal solid waste, 80% of the funds are spent on sorting it out. And difficult technology and all those things. So why do it? Because it is free, you are not encouraging. Supposing that plastic bottle was 1 rupee or 2 rupee, after we have left, you would have collected those bottles. We can create white collar thieves or good citizens who will be worried about the environment. We are not doing that. We are not doing that. You go to parties and marriage halls, right? You go to marriage. I have a suggestion. If some of you who are yet to get married, follow my suggestion. What is my suggestion? My suggestion is very simple. You give all sorts of food, Chinese, Thai, Malaysian, South Indian, Punjabi, Marathi, Gujarati, anything, right? And you have label, and people show their wealth by putting several dishes. And you go as a guest, you are tempted to taste everything. Okay? And you don't like it, throw it. more than 50% of the food is wasted. And why? Because it is free. But suppose there was a label. This dish will cost you 50 rupees or 100 rupees. And this 100 rupees will be given to the bride and groom at the end of the thing. They will get the gift also. There will not be any waste. And your wife will not allow you to touch any dish which you don't like. That is going to be the advantage. Because it is free, you throw it. If it was not free, you will not throw it. I can assure you that. So if the bottle was not free, I have paid deposit, I will return that bottle and take my deposit. And I will encourage digital economy. So maybe I have a barcode, okay, that boy comes and gives the barcode, he takes the bottle, 95 paisa back, 5 paisa his commission. So we create generation, we have jobs also, right? So this is what is important and why it is important, and I will tell you how hydrogen is going to help us. So chemical recycling, upcycling and downcycling. Green hydrogen will be the key here. So we have plastic waste recycling. Some of these things are tried right now, but I am suggesting more than that. That is so-called thermal, hydrothermal process, chemolysis, pyrolysis, gasification. So this way we can segregate plastic. For example, chemolysis, hydrolysis, glycolysis, aminolysis, ammonolysis, alcoholysis, acidolysis, by which we can break the backbone of the plastic, and that is a very good quality fuel. We have million tons of plastic lying everywhere. We are paying a cess on this in Swachh Bharat. Why not use it for good purpose? Supposing IIT director says, okay, collect the plastic and I will give you money, or maybe extra 5 marks. Everybody will collect it. Because there is an incentive. If there is no incentive, you will not do it. So same is the case here. So listen, what is the use of hydrogenation? Because even if you have a mixture of this plastic, in other cases you have to segregate. In hydrogenation, you don't have to segregate. You can take anything, mixture. We are doing some work in my lab on this. So whenever you have chlorine, nitrogen, oxygen, sulfur, what does it happen? It makes PVC2, HCl, water, ammonia, H2S. These are well-developed technologies in refineries. So we don't have to develop another technology. Only interesting part is collecting this, making pellets or making small particles and doing the hydrogenation reaction. That is what is required. So see what happened. I can take anything, glycolysis, hydrolysis, ammonolysis, phosphorylasis, dehydrochlorination, pyrolysis. All these things can be done on any plastic. And hydrogen plays the most important role in all this. So for example, PET waste cycle. You see, PET, I can do many things. PET, just simple PET. 80% of the PET is recycled in India. So there is a problem in PET also. You have the top bottle, which is mostly blue color, the lid, or green. So it contains some pigment. The plastic is PET. You can recycle, 80% is recycled. Reliance has a big recycle problem. But the bottle is another problem. The top is another problem. And then you have the paper. So why not devise some new technology where you don't use paper? So you reduce the wastage source, and that is what is required for all these things. And another problem is here, that is steel industry. Biggest pollution industry, steel industry. For example, we produce in 21 102.5 million tons capacity steel. Last year it was supposed to be 120 million tons. In 2030 it will be 300 million tons. And 1 ton of steel produces 2.38 tons of carbon dioxide. So it's a huge carbon dioxide, and we are talking about net zero. So the steel industry is interested in green hydrogen. That requires little different technology than what they are currently doing. So yes, so you can see you have electricity source, green hydrogen. You can see that you can have green steel industry. And this is what I told you about 2.38 tons of CO2. So obviously, hydrogen is going to be the savior of the world. In all these processes, wherever there is a pollution, hydrogen can tackle it. That is what I am trying to tell you. So when we have thermochemical, electrolytic, photolytic, these are mostly studied. PME electrolyzer, alkaline electrolyzer, solid state electrolyzers. And see the maturity. These are the bracketed ones, are the mature technologies which are there in the market now. So what we did, we looked at all technologies, steam methane reforming with carbon capture and all. Look at this. The cost and the capital cost is given in $1 million cost. Okay, it varies depending on the source. We studied 19 of these. And last is mine. And so in comparison with all these cases, my process which we develop, which does not use electrolyzer, which is thermochemical process, shows the great promise. And that is why government also wants us to do this thing. So what is the future cost of electrolytic hydrogen? See, they say it should be less than $2, including operations and maintenance. So that is a benchmark, because even the gray hydrogen you refine is $2. Okay, that is what it is. So by 2030, hydrogen economy will be a reality across the world. But the problem is, people are worried about hydrogen. As I mentioned to you before, they think it is a hydrogen bomb, atom bomb. So you know, in history of science teaches us something very interesting. You know, in 1910 around, in New Jersey state in the United States, the ladies took a morcha, a procession to the governor's office. They said, ban X-ray machine. It is depriving the women of their modesty. Can you show any hospital without X-ray today? That is the basic tool. So what happened during Second World War? This, because of the Hiroshima, Nagasaki, people are worried about atom bomb, right? Nuclear, the word nuclear itself is a taboo. So NMR, your MRI in hospitals, they drop the word N. Otherwise, it is NMRI. Why? So that people accept the technology. So sometimes you have to fool the people to accept the technology. And this is the best part of the example. So yes, so what is going to happen? In 2050, we will require 539 million metric tons of hydrogen. And 2070, when India says we will be carbon neutral and all, we require 700 million metric tons. India's population will be, by that time, almost 25% of the world. Remember, we require hydrogen more than anybody else in the world. So of course, so this is going to happen, hydrogen economy. So this is the course. If society accepts, then regional trains, coaches, SUVs, taxis, everything will be based on hydrogen. Ships and whatnot. So two-wheeler, three-wheeler. So you will have hydrogen fuel cells. You will have directly hydrogen used for IC engines and all. You don't have to do much modification. So usual steel, ammonia, methanol refining, that will happen. But this is going to happen. So what is the hydrogen safety? By their nature, all fuels have some degree of danger. So it is any, but now we have very good sensors, right? In our life, every day we are facing sensor right from the mobile phone. So these are very accurate. Gone are the days when you were worried about anything, even ppm and ppb can be sensed, right? So we have sensors, so we can sense even if there is hydrogen leakage. And hydrogen is 14 times lighter than air, so it goes in the atmosphere. So all these technologies, they have done simulations and whatnot. They found hydrogen is safer than most of the fluids. So hydrogen fuels are zero emissions, heavy duty. Hydrogen is commercial, can be produced. Hydrogen fuels are all real world. So hydrogen fuel cells is, people are talking, Nitin Gadkari is using it in Delhi, hydrogen, okay? So hydrogen is safer than conventional fuels. While no fuel is 100% safe, hydrogen has been shown to be safer than conventional fuels in a number of aspects. That is the fact of the matter. So to summarize, each work has to pass through, Swami Vivekananda said this, ridicule, opposition, and then acceptance. So in the case of hydrogen also, people 10 years ago, they were laughing at it. Now they are talking, governments are spending money across the world, including our government. So it is becoming a reality. Hydrogen is here to stay, like water. Yes. So then we can talk about green economy, bioeconomy, bio-based economy, circular economy. These are all related terms. And as I told you that hydrogen is going to play a very, very important role. Ladies and gentlemen, to make a zero-waste society, we have to have this great concept, reduce, reuse, recycle. And I told you that recycle engineering will be a great thing, whether it is materials or energy. And of course, recovery, landfill. And the whole objective is to make landfill zero. So our future challenge is to make landfill zero. Everything has to be reused in some form or the other. So this so-called system engineering approach, only useful material goes in, useful energy comes out, useful material comes out. Everything else is recycled, reused in some form or the other, and everything is a efficiency. We will try to increase the efficiency of each and every process. That is what we are going to do. So ladies and gentlemen, so green hydrogen will be the savior of the world. Carbon dioxide should not be a liability but an asset to convert. Remember, so carbon dioxide is a fuel, as I said. That is the reason I said. And waste biomass sustainability through waste minimization, recycle engineering, circular economy. Hydrogen economy can be elegantly intertwined to make many chemicals from waste carbon sources, including biomass and C1 gases. And government of India should adopt hydrogen economy to meet the demands of Paris Agreement, because we are party to that. So we must not look forward to 2070, but saying that tomorrow we must do. Then only technology will be developed. We must believe our scientists, engineers, and industries that they can do it. We have to have policies which will encourage all of them to come together. In fact, I've been saying that industries must collaborate very vociferously with academic institutions. There is no fear, right? At the most, you will fail. What is going to happen? If you do experiment, you will fail, but you will find something else. So this is all required. So ICT, OIC, hydrogen is very promising. I'm not going to say it. It will be foolish on my part if I say that is the only technology. No, we are one of them. We are one of them, and we have achieved success. And so this is the only way to meet the goals of the Paris Agreement, and we can make it, right? We are talking about Make in India. We can make it happen. So ladies and gentlemen, you know, all professors go outside and give big lectures. I'm one of them. And the students work in the lab. Of course, they might be deriving some inspiration from me, but yes, it is hard work by them, and I must dedicate my lecture to all of them. Thank you very much, and I'll be very happy to answer any questions. If I have not broken your sleep, well, my job was to keep you entertained. You have any questions, you can ask me. Yes, please. Yes, yes, yeah. Yes.
Right? Because we, as a chemist, convert the monomer into a polymer. Now, the question comes is that actually if you take a polyalkanes, right, you don't have any functional group.
No, you make only hydrocarbons. For hydrogenation, you make hydrocarbon. You crack it, no? It is hydrocracking. It's cracking, and that is what you make small. That is what actually thermal cracking happened, no? That is how you broke the molecule. But hydrogen is the key in all these things. Whether it is polyalkanes or anything, and all this biomass contains oxygen in that. Right? So that is why hydrogen is the key in this. Yeah, please. Yes, Professor.
Thank you, sir. Very nice talk, very
you.
comprehensive. I think you have very rightly said hydrogen and ammonia is the future, particularly for transport sector. I would just like to draw your attention that this CO2 problem is contributed only 16% by transport sector. Remaining about 70-75% is by electricity generation, cement industry, steel industry. So until and unless we tackle this problem in right earnest, this problem of net zero cannot be tackled. So any comments on that?
Yeah. So what I'm saying, I have a very simple solution. Don't use any carbon for any of these industries for energy supply. That is the solution.
So ultimately what you are saying is that solar energy, you convert that, that's the primary energy.
Yeah, solar, wind, geothermal, others, even hydro and whatever, and hydrogen.
Yeah, there is one challenge here, and I think that really bothers me, is that today, you know, if you look at the reality and numbers, in India, we have about 40% solar energy installed capacity. But the International Energy Agency report says that it contributes about 1.8% of the electricity to the grid. So that means, first of all, these energies are very unreliable and cyclic in nature due to their very nature. Storage makes them completely unviable. I mean, storage cost today that is being debated, lithium ion batteries, mega storage is about 20 rupees per unit. So I don't know. I think this is right direction. We should never judge a technology based on the economics in the beginning, but at the end of the day, it has to meet those challenges. And I can also tell you that we are doing a lot of work on hydrogen,
Very good.
methanol, and
Hamid
ammonia. So I'll be very happy to show you the application side. Thank you.
Very good. Thank you very much. I will tell you something interesting. You know, because solar energy maybe 5-6 hours you have, you require storage capacity, right? So in our case, what we did, we used molten salt. But of course, it has also efficiency issues. And we required about 550 degrees Celsius. So we have to ensure that we have that much energy in our cycle for running it 24/7. So very recently, somebody came from MIT. They have a startup company. And that man, so ONGC, Thermax, NTPC and all these guys, they were interested. So I was invited to comment by ONGC. And one of the things that fellow was saying that, he will heat air to 900 degrees C and that air he will use for producing. Just imagine what is the heat capacity of air, how much compression you require. So I said, can you show it how you do it? He says, yeah, during the day, photovoltaic. But during night, the heat I will use to run the turbine and make electricity by using air. So look, I said, I wish you all the best, but simple calculation shows it is not possible. If you are use some thermic fluid, it cannot go to 900 degrees C. Thermic fluid will crack at 400, 450 degrees C, any hydrocarbon for that matter. So molten salt, yes, it can. So that is how we started with molten salt. But anyway, every technology has a chance. As an engineer, I believe every technology has a chance. And unless it is implemented, tested, and technology is not developed overnight. It is not developed overnight. Government may say, hey, do it within 1 year. Nobody can do it. Typically, you look at all historical technologies, 10, 15 years have taken to stabilize it. Even initially, the economics may be totally against, but the idea works. And then what you will do? You will improve the efficiency. You will modify the equipment. Maybe you change the material of construction. Maybe you do something internally, heat pinching, this and that. So technology development is the most important part in all this green energy, blue energy, whatever energy you call. And you rightly said, because unless I make use of each and every source of energy, it is not going to be 100% hydrogen, not 100% solar or 100% wind. Wherever it is applicable, you should use that. But ultimately, the consumer, what the consumer is interested in, he should get electricity. He doesn't care whether it is coming from burning coal or hydrogen. He wants electricity. So as scientists, engineers, our job is to serve society. And this is the only way we can serve society. We can produce. So I can assure that I've been working with industry last 42 years as a consultant all my life. I have not taken a single penny of government for last 22 years. All my research is funded by industry. All my PhD fellows, my postdocs get 1 lakh rupees. I tell industry, I will not hire them if you don't give 1 lakh. If you give them 25,000, you will get that kind of quality only. If you want talent to be there, you have to pay talent. Remember that. You have to pay talent and we have to try hard. Industries don't give money just like that. If they give 1 rupee, they want 100 back. That is the fact of industrial collaboration. So yes, and every technology, I wish you all the best. In fact, it is required. Everybody must try. And you see, it is like, it is regional. Some of these technologies are regional. It is not universal. I would never say that. Technology is not universal. It is regional. It depends what source of material resources you have and you work on that. Yes, please.
Maybe the last question for the evening, sir.
I have no problem. I can talk till dinner if they serve me. Otherwise, I'm fine.
Even though chlorine is used in chloralkali industry at
Say it again.
chlorine
Huh?
at low temperatures in chloralkali, it's when you go to thermochemical cycle, The corrosion issues will be very significant.
Yeah.
The capital cost of these plants.
So you know what we did is a very good question actually. So what we said, let the idea first work. Then corrosion is a second problem. So we started working on that. I'm a chemical engineer. Then I had to work in materials also. How do you develop good material which will be corrosion free? So in fact, I could develop some better idea than that, where there is no corrosion. So, it's a good question, but corrosion, why that Qutub Minar is not corroding? Think on that.
On that note, I'm very sorry to interrupt this interesting conversation. It was a brilliant presentation, brilliant talk, very exciting and entertaining as well.
Thank you.
Let's have a round of applause for the speaker today.
Thank you.
May I now request Professor Vinod Singh to do the honors.
मैं नीचे आऊं क्या उधर? Thank you. Thank you so much.
Thank you all. Thank you all for joining us for this informative and entertaining talk. Thank you.